In this clip, we will talk about conditional probability. We've changed our current back a little bit so that it's easier to talk about. The previous one was nice, but yeah. We're gonna have our back as just integers so that we know for sure, like, this is 1, 2, 3. Okay. All right. So let's start with the review question. So this is our sample space, and let A be an event that you get an outcome which is divisible by 3. So what is PA? So how to figure that out? We need to basically count, right? We want to count the number of outcomes which is divisible by 3. So this is 1, 2, 3, right? So it's going to be 3, and the number of possible outcomes is 10. So this is 0.3. So that's the solution. So let's look at another review question. All right. So we have two events. One is A and B. A is the event that you get the outcome divisible by 3, and the other one is divisible by 2. Okay, so what is PA? We have already computed that, which is 3/10. What is PB? So again, you count the number of outcomes which are divisible by 2. So this is 1, 2, 3, 4, 5. So this is 5 or 10. And that's 0.5. Now P union B, how many of that? So it can either divisible by 2 and 3. So I'll wait for you to figure that out. Right. Okay, the answer is 7/10. Okay, and A intersection B. So this number is divisible by both 2 and 3. Can you find one? All right, so it's 6. So you get 1/10. All right, so this is just a review question. All right. Right. So we will look at a modified situation. So previously we have a bag, right? And we pick here, okay? And we pick something from the bag and take a look, okay? Now someone just came here and take a look at the object for us first, okay? And then he leaks some information is leaked to us, and before we see this, we hear something from this person. Okay, let's have someone here, and then yeah, so that's the situation. Okay, someone leaks some information to you before you see the actual outcome. So let's look at one example of that. Suppose we have the same sample space, and we have set A be an event that you get an even number. Now suppose that yeah, we already know that probability of an event A is 1/2. Now, but before we know that, someone just came to us and say, okay, the number is not only that you pick this number from the bag, but it's divisible by 3. Okay, is that is this information is gonna change your beliefs, or is it gonna change the probability that you get an even number? Right. So let's look at some before and after situation. Let me note again that by telling you some information, it probably doesn't change the result, but the fact that some information is that way probably has an effect on your beliefs. That's what we can think about it. So before you are, you're interested in this red circle outcomes, right? Now someone tells you that it's divisible by 3. So now what's the picture would look like? You suddenly know that, okay, it's not possible for me to get 1. This is not possible. This is not possible. It's not possible for this. Not possible for that. That too, and that. Okay. So, but what's left is these 3 guys, and they are all equally likely. From that, we can now we know that we would end up with any of these guys with the same probability. So what's the probability that we get an even number? Okay, so we only have 1 left, right? So we have 1 left out of what's left. We only have 3 possible outcomes. The outcome that we are interested in is just 1. So this is the new probability that you get an even number, which is decreased from 1/2 here, because you know this fact. All right. So the concept of conditional probability is probably one of the single most important concept in probability theory. So we would like to spend more time on these topics so that you really understand it, and we're gonna do that for sure. All right. So now we look at the probability model, which is kind of simple. So maybe it's the example probably won't convince you that it's really interesting. So let's look at another example. But now we're gonna change the model a little bit. So and in this case we cannot really analyze it as clearly as we did before, because now we're gonna have 1 bag and we're gonna pick 2 numbers from it. Okay, so it's different from the first model. All right, but I hope this gives you some hints of why conditional probability is kind of to be fun. Okay, all right, so let's look at the new model, and then we'll come back to this new model later on. Okay, okay, so in this model we have a bag again, and we have 10 numbers in this bag. Okay, and there are 2 players. The first player, okay, picks some number from this bag and takes it. Okay, and the second player comes and take the next one. So so for the second player, she only has 9 choices. Okay, and from this, who gets the larger number wins. So for under normal conditions, so if you are a second player, what is the probability that you win? So if we're gonna focus on the previous model, we have to draw like a bag, but then you pick 2 things from the bag. So how are you gonna reason about that? But now we're gonna do it informally. All right. So because there are 2 players, and you get some number, right? First one gets some number that you don't know. The second one get another number that you don't know either. All right. But these 2 numbers are different. So what's the probability that the second one has a higher number? Yeah, because for whatever pairs of number these 2 people get, there's another possible outcomes that they exchange number, right? So in this case, picking 2 numbers, what's the probability that one win is gonna be like equally likely? So the probability that you win. So we're gonna analyze this rigorously later on, but now just believe me. So it's 1/2. So, because it's a kind of fair game. You just pick 1 number, different number, randomly from a bag, and you don't know, right? So the probability that you win equals the probability that the other people and the other person win. So yeah, it's 1/2. Now suppose that you happen to know that the other person get 5. What's your chance to win now? So what's are the number? Number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you know that the other person already get 5, right? Okay. Now you have 9 choices left. And you see that there are 4 choices that you would, lose. And there are 6 choices that you could win, right? So the probability that you win is there are 5 ways that you can win out of 9 possible choices. So this is the probability that you win, which is a little bit higher than 1/2, right? A little bit higher. So it's like 0.55555, blah blah blah. Okay, that's a good case. So let's look at another case. So if you know that the other person gets 7, so what's your chance to win now? So let's 2, 3, 4, 5, 6, 7, 8, 9, 10, and this one is gone, right? So your ways to win is 3 out of 9. So that's just 1/2. Maybe you don't want to play it this time. So this is the kind of changes that affect your chance to win and your calculation of probabilities because you know something. Let's go back and look at the previous example for a little bit. All right. In the previous example, we talk about the event that we are interested in, event A, which is that you pick an even number, and then we know that another event. We know that we actually pick a number which is divisible by 3. Now, think about, if you really think about it, you can see that the fact that the number is divisible by 3 is also an event. Okay, so when we talk about the probability that you get an even number when the number is divisible by 3, we're talking about 2 events. One is the when we say that you get an even number given that we know that the number is divisible by 3, is 1 over 3, 1/3. We are talking about 2 events at the same time. One is the event A that we are interested in. Another is event B. Okay, and event B is the condition on which the event A occurs. Okay, so it's about 2 events. Okay, do you see that? Do you see that it's 2 events? All right, and we have a notation for this. So suppose we have 2 events, A and B, and the conditional probability of event A given that B has occurred is written this way. Okay, you just put this dash, this line here, saying that probability of A given B. So this is pronounced as given. All right, so let's do some example before we finish this segment. All right, so we have an event A to be the event that you pick an even number, and B is an event that the number is greater than 5. Okay, so what is A over B? So first of all, we know that B occurs, right? So let's try to kill off all other outcomes which is not in the event B. So it's greater than 5, so bye. Okay, so you are left with this. Okay, so what is the probability that you pick an even number? So there are 1, 2, 3. So it's 3 over 5. Okay, now suppose I change this from 5 to 6. What would it be? Okay, so if this is 6, then this one is also gone. So you have the the outcome that belongs to event A is there are only 2 outcomes. So you have 2 out of 4 remaining. So this, and this is 1/2, and this is equal to the case when you don't know B, right? You don't know that the number is greater than 6 or not. All right, so let's look at another example. Now, let A be an even that you pick an even number, and B be an even that the number is a prime number. How to we want to find a P of A given B. Okay, so I'll give you a minute, a few seconds to think. So what's this? All right, so it's so let's kill off the non-prime number 1. So you have 1, 2, 1, 2, 3, 4. 4 numbers left. And in the even number, there's only 1 left, right? So it's 1/4. Okay. So the last example, let A be an even that you pick a prime number, and B be an even that your number is divisible by 2. What's the answer? Okay, so there are 5 outcomes left, right? Because and then there's only 1, so 5 outcomes left. There's only 1 which is prime number, so it's 1/5. All right. From the previous example, we've seen what's the conditional probability, and we compute it probably essentially manually. Okay, but there's a nice formula that compute this value. Okay, based on the probability of other events. Okay, I believe you can, if you go back and look at what we've done, I believe you can figure it out. Okay. So please spend a few minutes thinking about it before watching the next segment. All right, see you there. Bye.